Water covers 75% of the Earth's surface. Yet for all our technological progress, we have explored barely 5% of it. This gap in our knowledge is significant. The ocean produces up to 80% of our oxygen and is home to an estimated 91% of the planet's unknown species. While our own waters remain a mystery, we are spending billions to map and travel to other worlds. We are looking for life on a planet millions of miles away, while ignoring the majority of life on our own. Humanity is effectively overlooking its own primary life support system to study the geology of dead planets. For every 10 meters you drop, water pressure increases by 1 atmosphere. At the Mariana Trench floor, pressure is 1,000 times higher than the surface. A human body here would experience a crushing force equivalent to 50 jumbo jets. Water density also creates a barrier for light. Red light is absorbed within the first 10 meters. By 800 meters, all visible light has been scattered, resulting in a total blackout. This density makes standard remote sensing technology, like radar, ineffective. Radio signals cannot propagate through the water and fail completely after just 20 meters. The sheer scale of this dark environment makes search efforts incredibly difficult. It took 73 years of searching to locate the wreckage of the Titanic. More recently, the disappearance of Malaysia Airlines Flight 370 required a year of searching just to find a single piece of the aircraft. The combination of extreme pressure, absolute darkness, and the vast volume of the water makes the deep ocean appear physically unconquerable. These physical conditions are daunting, but they may be functioning as a narrative for our lack of progress rather than a hard limit on our capability. Deep-sea temperatures hover near freezing, but we have already mastered survival in the much harsher -270-degree vacuum of space. We use thermal suits to regulate temperature in orbit. The same principles apply in the ocean. We have also solved the problem of pressure. Specialized submersibles use thick, anti-corrosive metal plating to withstand the weight of the water, allowing us to reach the deepest trenches safely. To see through the darkness, we have moved beyond visible light. We use sonar and acoustic imaging, which use sound waves to map the seafloor with high precision, bypassing the limitations of human sight. Humanity possesses the technology to explore the abyss. The decision not to do so is a matter of collective motivation. Part of our hesitation is biological. Thalassophobia is an evolutionary fear of deep, unknown water. As a land-based species, we are wired to be wary of environments where we lack visibility and control. When we are deprived of visual information in the dark, the brain often fills the void with hallucinations. This is why we have populated the deep with myths of monsters and legends of the unknown. Our fear is often disconnected from the actual risk. The odds of dying in a shipwreck are microscopic compared to the much higher probability of a fatal car accident. This psychological wiring actively discourages us from looking downward, overriding our scientific interest with a primal urge to stay on the surface. Beyond psychology, there is the reality of institutional funding and political primaries. When NASA was founded in 1958, it was given massive financial backing and a clear mandate to reach the moon. In contrast, NOAA was established 12 years later for oceanic research, but with a significantly smaller budget. This funding gap was set in place during the Nixon administration, which prioritized space exploration over the study of our own oceans. The ocean remains a mystery because we have chosen to look away. We have the engineering to reveal its secrets, but we continue to let systemic underfunding and evolutionary fear keep our attention fixed on the stars.